Bismillahir Rahmanir Rahim. Newton's laws of motion. There are three basic laws of motion which were given by the Newton, a great scientist, and he published them in his book Philosophia Naturalis Principia Mathematica. He published them in his book Philosophy Naturalis Principia Mathematica, means mathematic principles of natural philosophy in 1687. What is Newton's first law of motion? According to Newton's first law of motion, a body at rest will remain at rest and a body in motion will continue its motion in the absence of net force. It is also known as law of inertia, and according to this law of inertia or Newton's first law, an object at rest tends to stay at rest and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by the unbalanced force or outside force. Briefly, we can say that the velocity of an object remains same unless acted upon by an unbalanced force. It means that a body lying on some surface, if it is at rest, then it will continue its state of rest. And if the body is in motion in the space or on the surface, then it will continue its motion unless and until an external force tries to stop him. Law of inertia. Newton's first law is also known as law of inertia. This is because of the property of an object tending to maintain the state of rest or state of uniform motion, and this property is referred as object's inertia. If we say a body has more inertia, then it means that body has more ability to resist the change in its state. For example, if a heavy body is moving and we want to stop that heavy body, then it's very difficult to stop that body because that body has more inertia and it does not want to change its state of motion. And if a lighter body is moving and we want to stop the lighter body, then it becomes easily stopped because of the reason that it has lower inertia. It means inertia is related to the mass. The mass of the object is a quantitative measure of its inertia. If the mass is high or the body is heavy, then its property of resisting the change in its state is more, means inertia is more. If the body is lighter, then it has less inertia or less property of resisting the change in its state. What is the force? Technically, force is something that can accelerate objects, or an agent which tends to move the body is known as force. And the unit of force is Newton, and 1 Newton is equal to 1 kilogram meter per second square. A definition of 1 Newton is in such a way that if a force of 1 Newton is applied on a mass of 1 kilogram, then it speeds up that body, the motion of that body, with the rate of 1 meter per second. And this force is equal to 1 Newton. It means that 1 Newton force is a force that accelerates a body with the rate of 1 meter per second. If a 1 kilogram mass is applied a 2 Newton force, then the 1 kilogram mass will speed up or increase its speed 2 meter per second. It means more force, then there will be a more rate of increase of speed or acceleration. So a force is known as 1 Newton if that speeds up 1 kilogram mass with the acceleration of 1 meter per second. Newton's second law of motion. Newton's second law is very simple, and it says that if a mass is applied a force then that force tends to move that body, but that force moves that body with the increasing speed or acceleration. It means that when a force is applied, then acceleration is produced in a body. And that acceleration is inversely proportional to mass. If the mass is more, then acceleration is small. If mass is further increased, then acceleration will further decrease. It means that a lighter ball, a lighter mass, will speed up more rapidly by applying the same force, and the heavy masses will speed up slowly, but there will be a speed up process or increasing the speed process, or there will be an acceleration when the force is applied. And if the body moves, then it will move with the acceleration. Similarly, if the mass remains same and the force is increased, by increasing the force, acceleration increases. It means that acceleration is directly proportional to force and inversely proportional to mass. So acceleration is inversely proportional to mass and directly proportional to force. And if we combine both relationships, then we will get the F is equal to ma. As we know that A becomes directly proportional to F over m, and equality sign, for the sake of equality, we place a constant k, and that value of constant in the practical scenario, in the real physical world, the value of k is equal to 1, and with the value of k is equal to 1, the ultimate relationship becomes F is equal to ma. So F is equal to ma is the relationship for the Newton's second law of motion, and this Newton's second law describes that the acceleration of the object is directly proportional to the net force acting on the object and inversely proportional to the mass. If the net force is parallel to the velocity, then the speed of the object increases. By applying this force red vector, the speed suddenly increases, and if the force is anti-parallel to the velocity, then the speed of the object decreases. It means that force generates the acceleration. Acceleration means change of velocity. If the force is applied, then in the same direction with the same directional force, the speed of the object increases, and with the opposite direction of the force, the speed of the object decreases. And you see that the body slows down by applying the opposing force. It means that the speed changes, there is also acceleration, but negative acceleration. But if the net force is perpendicular to the direction of velocity, then the velocity does not changes its magnitude, not it slows down and not it speeds up, but it only changes the direction. For example, if the body is moving in this direction, force is applied, then the body will move in a curved path and tries to move in a circular path. What is Newton's third law of motion? According to Newton's third law of motion, action and reaction are always applied in the phenomena when two bodies interact with each other. It means that whenever one body exerts a force on a second body, the second body exerts an equal and opposite force on the first body. For example, and this action-reaction forces is known as action-reaction pair. For example, if the computer is placed on a table, then computer exerts a action force on the table surface, which is in the downward direction. And the table surface or the wooden board of the table reacts in the upward direction. If weight of the computer is too much high and computer table does not become able to respond or react with the same force, then the board will break down or the table will break down. It means if it does not break, then action force downward and the normal upward forces become equal, and this action reaction pair balances each other. Similarly, if you weigh on the weigh machine, then you apply a force on the weigh balance in the downward direction, and the weigh balance reacts you or applies a force in the upward direction for the sake of reaction. Similarly, if you are hanging from a tree or something else, the weight tends to move down, but the reaction force from the tree you will up. Thank you for watching the video. Please visit the website www.kencolly.com for more information.